Alright, so now let's apply what we learned in regression with some of the illustrative examples. So with the first one, two lines of regression are 4x minus 5y plus 30 is equal to 0, and 2x minus 9y is equal to 56. Calculate coefficient of correlation between x and y. Calculate coefficient of correlation between x and y. All right, so let's zoom into the solution. You have to find the r. That's what they're asking us to find. Find r, which we don't know. Okay. So in our previous study, based on the previous video we did, so let's assume we are following the step. Let's assume that our first equation is equation x on y. Our first equation is equation x on y, and our second equation is equation y on x. So with the first equation, we have 4x minus 5y plus 30 is equal to 0. Then the second equation, 20x minus 9y is equal to 56. Because the first equation is equation x on y, meaning that x depends on y, let's make x, which is now the dependent variable, the subject. 4x is equal to 5y minus 30. Now let's divide through by 4. Everything divided by 4 here. So now equation y, x on y becomes x is equal to, this will cancel this, x equal to 5 over 4y minus 15 over 2. Good. Now let's come here. Let's come to the second one, that is y on x. Y on x means that y is the dependent variable and x is the independent variable. So let's make y the subject. Negative 9y is equal to 56 minus 20x. Let's divide through by negative 9y. Negative 9y. So this will cancel this. We have y to be negative 56 over 9 plus 20 over 9x. Because here is negative, here too is what? Negative, so giving us a positive. When you're done finding the equations, we have this one as the equation x on y, and this equation y on x. The next step we have to do is to multiply their coefficients. If their coefficient is not greater than 1, then whatever assumption we did, but the question didn't specify whether x on y is this, the first equation, and y on x. We did our own assumption, but we have to test whether assumption is right. So let's test our assumption by multiplying their regression coefficients. So the regression coefficient x on y, looking at this equation, is 5 over 4. See, then regression coefficient y on x is 20 over 9. When we are done finding our regression coefficient, the next thing is to multiply. If we multiply x on y by regression coefficient y on x, it's giving us r squared. We're going to put this formula in our next question. Don't worry. So 5 over 4 times 20 over 9. what's the answer? 5 over 4 times 20 over 9, which is giving us 2.77. That is our R squared. And I told you in our previous video that it can be more than 1 or 100%. So meaning that if this is greater than 1, that our assumption is wrong. It can't be possible. So how do we do that? We would have to interchange the equations again by swapping this into this and also swapping this into this. So because our assumption is wrong, we need to redo it again. So x on y, and here is y on x. All right. So now let's pick the y on x to be the x on y. So here was x on y and was the first equation. So x on y becomes this equation rather. 20x minus 9y. 20x minus 9y is equal to 56. Then this equation rather becomes y on x. That's 4x minus 5y minus 5y plus 30 is equal to 0. Now we have interchanged them. Now. So let's solve them one after the other. So x on y, meaning that x depends on y. Let's make x the subject. 20x is equal to 9y plus 56. We want to make it, let's divide through by 20. Now x is equal to 9 over 20y plus 56 divided by 20, which is giving us 14 over 5. So this equation y on x, we have negative y is equal to negative 30 minus 4x. We divide through by negative 5, negative 5, negative 5, negative 5. Now y is equal to 30 divided by, that's negative 30 divided by negative 5. We are getting 6. Then here is negative, another negative here, which is giving us plus 4 over 5. Yes, so we are done with equation y on x. The next thing we have to do is to multiply their coefficients. That's the regression coefficient. So regression coefficient x on y is given by 9 over 20. Then y on x is given by 4 over 5. Now let's multiply them. X on y times y on x will give you the coefficient of determination as the R squared. 9 divided by 20 times 4 over 5. Let's see the answer. 9 divided by 9 by 20 times 4 over 5. 0.36, 0.36, which is less than 1. So our assumption is correct. So now we can go ahead to find your R. Now when you multiplied the reciprocal, you had the reciprocal regression coefficient, and the R. Now we want to find the R. So R is basically what? The R squared. And the R squared in this scenario is 0.36, which is giving us 0.6. Yeah, 0.6. So now your R, which is your correlation, is 0.6. All right, now the reason why we are getting, when you want to multiply irrespective the two regression coefficients is giving you R square is that. So we have in your previous video I told you to find the regression coefficient y on x given by correlation coefficient and standard deviation of y, standard deviation of x. Let's assume that this is equation 1. Then x on y r times standard deviation of x over standard deviation of y. Let's also assume that this is equation 2. So if you multiply equation 1 by equation 2, you are getting y on x times dxy. This is given by r. That's the first one here. Here, standard deviation of x multiplied by standard deviation of x, standard deviation of y. If we divide this one and multiplying, so we cancel this one to cancel. We are left with just two things here, r, r. R by r is giving us r squared. So b times equal to r squared. So therefore, if you multiply the two regression coefficient, you're getting r squared. Another thing that you should also notice, given two regression equations and you're being asked to find your r, there's no way. So let's listen. There's no way they'll give this one to be positive and this one to be negative. No, no. If they are all positive, they are all positive. And if they are all negative, they are all negative. But the problem arises if they are both negative. You see, if they are both negative, then let me pick. If they are both positive, finding your R will be what? Positive. That's given that if du on x is positive and du on x is positive, then your R comes positive because we are going to take square root of this one to find your R. Okay. Then another thing to note is if they are both negative, negative x on y, even though when you punch it on a calculator, as when you enter this value here on a calculator to find your R, multiplying, you would get a positive figure to be your R. But because they are both negative, when you are done, you have to attach a negative sign to your R, signifying that both of the regression coefficients were negative. Other than that, you get it wrong. Also note that there's no way they'll give you one, let's say y on x to be positive and x on y to be negative. No, this one, it doesn't exist. So if they are giving everything in positive, everything is positive. And if they are giving everything negative, everything is what? Negative. But the only difference is that if they are all negative, your R at the end should be what? Negative. Even though when you punch on a calculator, you're getting a positive figure. Okay. Let's solve the next question in line. Let's solve the next question. Find the regression equation of y on x from the following values. Mean of x is 10, mean of y 15, and regression coefficient y on x is 2.5. So looking at this and the information provided in the question, we can only use this y is equal to y minus y bar. As we are finding y on x is equal to regression coefficient y on x times x minus mean of x. So we have y minus mean of y, which is 15. We have 2.5 x minus mean of x. Then let's expand our bracket. Y minus 15 is equal to 2.5 x minus 25. Y is equal to 2.5 x minus 25 plus 15. So our equation becomes y is equal to 2.5x minus 10. So this is our equation. Let's solve the second one. If two regression equations are 8x minus 10y plus 6 is equal to 0 and 40x plus 18y is equal to 214. Find the average values of x and y. Find the average values of x and y. Find the average values of x and y. So in this scenario, if you have two regression equations and you have to find the averages, that's you have to find the average x and the average of y. How do you find it? So where we have two regression lines or equation, their intersection is give you the average. That's where they meet, where two of the regression lines meet. If they say the midpoint, the midpoint where they are meeting is their means or their averages. And how do you get their means? You get the means by solving this equation, two equations what simultaneously. So let's assume that the first equation is equation 1 is equal to minus 66, equation 1. And then the second equation 40x minus 18y is equal to 214, equation 2. Here we can solve it simultaneously either by using the method of elimination or the method of substitution to find for the x and y. So if you have to multiply 8, we are multiplying equation 1 by 5. So equation 1 times 5. So 8 by 5, we are getting 40x minus 10 by 5, also 50y, negative 66 by 5, we are getting negative 330. The answer is negative 330. So let's assume here is equation 3. Now, because here and here, so I'm doing the method of elimination. I'm saying equation 2 minus equation 3. So 40x minus 40x giving us 0. Negative 18y minus 50y. So you're getting negative 18y plus 50y, which is giving us 32y should be equal to 214 minus 330, 544. You want to find the y, we divide through by 214 minus, so it's giving us plus 214 plus 330, which is giving us 544. Sorry, we are going to get 544. 214 plus 330. Yeah, 544. So let's divide through by 32. 32. So now your y is equal to 544 divided by 32, which is giving you 17. Good. Now let's find the x. So now we have y. You can put y in any of the equations, but I'll put it in 1. Now put y is equal to 17 into equation 1. What's equation 1 is 8x. So 8x minus 10y. Now y is 17. So equal to negative we have 8x minus 170 to negative 66. 8x is equal to negative 66 plus 1. 8x is equal to negative 104. We want to make x divide both sides by 8. This cancels. X is equal to 104 divided by 8, which is giving us 13. So the average value of x and y, x and y is equal to 13 and 17. Let's solve the next question in line. Using the following regression coefficient, find the value of the correlation coefficient R, where regression coefficient y on x is equal to negative 0.6. Then regression equation coefficient x on y is negative 1.35. Negative 1.35. So now let's find our R. So given that b y on x is equal to negative 0.6 and b x on y is equal to negative 1.35. Let's find our R. So our R is given by square root of mu y negative 0.6 times 5. Take square root of negative 0.6 times 0.35. We are getting 0.9. All right. So under normal circumstance, because you entered all the negative on your calculator, we are getting 0.9. But bear in mind that the signs here are negative. The signs are negative. At the end, I should equal to 0.2. Let's take the last two questions. Let's take the last two questions. If mean of x is equal to 36, mean of y 85, standard deviation of x is equal to 11, standard deviation of y is equal to 8, and the correlation coefficient between x and y is equal to 0.66, then find the two regression equations. Find the two regression equations. So two regression equations. First one is x on y. The second one is y on x. Prepare the information given. We can easily use y minus. Finally use x minus mean of x to equal to the regression coefficient x on y minus mean. This one is given by y minus equal to x minus e. But here lies the case we don't have the regression coefficient. So how do you go about it? Given the correlation coefficient. To find the correlation, find the regression coefficient x and y. You simply multiply the correlation coefficient by the standard deviation of x divided by the standard deviation of y. So the correlation coefficient here 0.66 multiplying the standard deviation of x, which is 11, and the standard deviation of y, which is 8. 0.66 times 11 divided by 8, which is giving us 0.9075. Now let's find so x minus mean of x was giving us 36, should be equal to 0.9075. Y minus mean of y was giving us 85. So x minus 36. 0.975. 0.9075 times y is giving us 0.9075 minus 0.9075 times 85. We have 77.1375. So now making x the subject, x is equal to 0.9075y minus 77.1375 plus 36. X is equal to 0.9075y minus 41.1375. So this is our regression. Let's find regression equation y of x. Also, we don't have the regression coefficient, so we need to find it. Y on x is given by r times standard deviation of y divided by standard deviation. R was 0.66. Standard deviation of y was 8, and standard deviation of x was 11. Now your regression coefficient is given by 0.66 times 8 over 11, giving us 0.48. 0.48. Let's go ahead to find the regression equation y on x. So your y minus the mean of y was giving us 85. Now have b as the regression x minus the mean of x was giving us 36. Let's expand the bracket here. So we have y minus 85 to 0.48x minus 0.48 times 36, 17.28. 17.28. Let's make y the subject. 0.48x minus 17.28 plus 85. Y is equal to 0.48x plus 67.72. So this is our regression y on x. Let's on the last question here. So with the last question, you have standard deviation of x to be 10, standard deviation of y to be 12, and regression coefficient y on x to be negative 0.8. Now find the correlation coefficient. I'm giving you 2 minutes. Try your hands on that. Yeah, sure. So you know that regression coefficient y on x is given by your r, standard deviation of y over standard deviation of x. Now you've been given this, but not this. You have this and this. So let's make it the subject. Now we have y on x multiplied by standard deviation of x should be equal to r times. We divide both sides by standard deviation of y. Standard deviation of y. So your r becomes the y on x times standard deviation of x over standard deviation of y. Your regression coefficient y on x was given as negative 0.8 times standard deviation of x is 10 divided by standard deviation of y, which is also 12. So your r is equal to negative 0.8 times 10 divided by 12, negative 0.67.